Okay, in this video, I'm going to solve another problem about consistent deformation method. This time, the redundant is a member. Now, in my previous video, the redundant was a support at C, but having no member CD. But this time, the redundant is this member, capital CD. So, if we check the determinacy, this is the criteria. B, number of members. If you check the number of members, there are 14 members. And R, number of reaction components, there are 3. And for the number of joints, there are 8. So if you substitute 17 greater than 16, our classification is that Truss is statically indeterminate to the first degree. And therefore, there is one redundant. Okay. This is the original Truss. And to analyze, let's choose a primary truss. So for the primary truss, it should be a determinate truss. So we will remove the redundant. Okay. So we can select this member, small c, capital D, as our redundant, or we can choose capital C, small d as our redundant. Okay. Now, in order to make use of my explanation in solving for S prime, let's choose this member, capital C, small d, as our redundant. So let's remove this member. Okay. So this primary truss is similar to the previous problem I already solved. Okay. Regarding, using consistent deformation method. So we solve for the reactions RA, RE. And then summation of moment about A, we can solve for RE. And then sum up of force vertical, we can solve for RA. So next, we solve for S prime. We can use method of joins or my labay-labay style. This was explained already sa other video. A similar problem on this. Similar problem using consistent deformation method also. Okay. Now, since member capital CD is our redundant, then the value of S prime for this member should be 0. 0 na. Okay. And after this, we can start with joint A to solve for members AB and AB. So, similar to previous problem, first we get the slope for this inclined member. 32 over 24 is equal to 4/3. And this is special triangle, so the hypotenuse is 5. So, using my labay-labay style, it's a practical way of analyzing a truss. But the basis is that the total force, the total horizontal force must be 0, or summation of force sa x equal to 0 para ma-satisfy. And also, the total vertical force must also be equal to 0. Okay. Now, for an inclined member, let's resolve this one into components, horizontal and vertical. So, there are 3 forces: vertical component, horizontal component, and the force of member EB. So we start with one. One unknown. So we start with the vertical. Since horizontal, there are 2 unknowns, man. So by the purpose of labay-labay style is one. We start with the axis na isa ka unknown, isa lang na unknown. So we choose vertical. Now, so that the total vertical force be equal to 0, then we must balance this reaction by the same vertical component, same value. 48. Para i-add sa duha, sa two forces, 0 ang total. And to determine the horizontal component, we use ratio and proportion using this one, slope. Vertical, whatever is given, i-divide siya sa iyang counterpart. So, vertical 48 divided by vertical component sa slope 4, so 12. To get the horizontal component, i-multiply sa horizontal. So, 48 over 4, 12 times 3, 36. And then, to determine the magnitude, 48 over 4, 12 times 5, 60. So, member EB, capital B is compression, that's negative 60. And to balance this 36, the force of member EB must be 36 also. And since this is directed to the left, AB must be directed to the right. So, tensile, so it's positive 36. So we can now say that joint A is in equilibrium. So after this, labay, transfer these forces to the opposite joint. So 36, since tension, it must be away. So opposite ang direction. So analyzing joint B, this force will be balanced by BC. So BC must be positive 36 also. And for this vertical member, this will balance 64. 64 keeps downward will be balanced by 64 keeps upward. Positive, not tension. After this, analyze capital B. Labay na to eh. Labay, transfer. And then this force transfer po dire. Labay. Okay, and then for this member, diagonal, we have components, and then we start with vertical. Since we only have one unknown force of vertical. One vertical force, two horizontal forces, horizontal component, and BC. So we start with vertical. Okay. We have 48 upward. This is 64. 48 upward, 64 downward. So we need 16 upward para ma-zero ang vertical. So to get the horizontal component, we use ratio and proportion. Again, 16 vertical divided by vertical 4 is 4. 16 over 4, 4 times 3, 12. So the horizontal component is 12. And to get the magnitude, it's 16 over 4. 4 times 5, this is 20. Compression. And then to solve for BC, let's check on the horizontal forces. 36, 12. So kulang og 24 to the left. So it's negative 24. Compression. And then labay joint C, 24. Now, since this is 0, this force will be balanced by CD. To the left. Okay, right money. To the left. So it's negative also. Negative 24. For CC, since this is 0, 0 sa di. After this, joint C, having two unknown members. So this one, these components, labay dere, transfer. 36 transferred also. And then 0. And then diagonal, get the components. We start again with the vertical. 16 downward, it will be balanced by 16 upward. And then horizontal component, check. 16, same money, 16 vertical, 12 horizontal. And for CD, Check horizontal forces. 36 left, 12 right, 12 right. Kulang ka og 12 right. Positive 20, sorry. Magnitude, positive 20. And for CD, 12 positive. And then transfer to D, 0. So DE is positive 12 also. And DD is 0. Next, we move to joint E. Transfer and 12. And then component 16 will be balanced by this component 16. Same ratio. This is 12 also. So check horizontal balance. And to make sure na correct, we will check joint D. So joint D, we have these components 12, 16, and then 24 compression, and then 0, and then this diagonal tension 16 and 12. Okay, we look at the horizontal forces, balanced, vertical forces, balanced. So the analysis is correct. Yeah. Okay, so next, we solve for U, values of truss members due to unit load. Okay. Now, since our redundant is a member, we will apply unit load sa two joints, joints C and D. Okay, apply a unit load at joints C and D. Okay, now we'll assume na tensile ang force. Okay, the value is 1, unit load man. And not D, tensile also. 1. Okay. Now, we get the components of this. 0.8. How did we get 0.8? Ratio and proportion again. 1 is inclined, so 1 divided by inclined 5. 1 over 5 is 0.2 times vertical for its 0.8. And then times 3, 0.2 times 3, it's 0.6. Same with this one, 0.8 and 0.6. Now, if we will sum up moment about A, having these forces, the reaction at A is 0. Why? Because the magnitudes 1 and 1 are collinear. Collinear, so wala moment. Zero moment. So, dili sila couple. Kay collinear man. So, the moment of these components will just be cancelled by these components. The moment of these components, 0.6 and 0.8. Okay. So therefore, the reaction at E is 0. And nag-balance lang man eh. Horizontal, to the right, left, downward, upward, balance. No? So 0 and 0 sa daang RA. Okay. So, this will now be very easy. Okay, 0. So, analyze joint A. 0, 0. So, 0 na. 0 component, 0 magnitude, 0. And then sa B, 0, 0, 0 also. Now, sa joint C, there is 0.6 to the right. So, this will be balanced by 0.6 to the left, or simply negative 0.6. 0.8 will be balanced by this member CC. Downward to upward na. 0.8. And the next transfer 0.8, 0, 0. Okay. This force will be balanced by this. So 0.8 balanced by 0.8 upward. By ratio and proportion, 0.8 over 4 is 0.2 times 3, 0.6. And the magnitude is 1 also. Same with this, no? With components 0.8 and 0.6. Okay, so the force of this member CD is positive 1. So at joint C, if we check the horizontal forces, there's a 0.6 to the right. No? So i-balance 0.6 to the left. And if we transfer, balance ang horizontal, 0.6 to the left, 0.6 to the right. Therefore, this member is 0 na. And then for this one, DD, 0.8 upward, so it will be balanced by this, 0.8 downward. Okay, next, joint E, 0, so 0, 0 ang member. So, if we check joint B, 0, 0.6 compression. This one is 0.8 compression. And this member is, tensile. So check horizontal forces, balance, vertical forces, balance also. Okay, so after this, construct a table. Okay. Sige. Sa table, okay. This is the removed member. Remove member N. Sa S prime, 0 siya. And sa U is positive 1. So, there are only 6 members na value. This one, 1, 2, 3, 4, 5, and 6. So, 6 lang. 1, 2, 3, 4, 5, 6. The rest, 0 na. Okay, so to solve for delta, mostly ang U is 0. So, S prime times U, L over E is 0 na. 0, 0, 0, 0. This one, there's a value. S prime times U, L over E, negative 0.00024. U 0, S prime 0, so 0 sa, okay, 20 times 1, L over E, U 0, so 0, S prime 0, 0 sa S prime 0, U 0, U 0, and this one. So, next is i-add, and then this is the total. Next, delta, U squared L over E. So, for 0, U, 0 tanan. 0.6 squared times L over E, we have this one. U squared, 0, 0.8 squared L over E. 1 squared L over E. 0, 1, same lang ayo. 1, same value. 0.8, same U 0, 0, 0.6, same sa na value. And i-add after this compatibility equation. Okay, substitute. This one. And the redundant is FDC, force of this member. So we have FDC equal to negative, which means na compression. Because ang assume na to is tension. No? The assumed direction is tension. And then ang negative siya, so it means na compression siya. So next is compute for the correct value of the force of the members. Again, to solve for S, it's S prime plus U times redundant. But since U is 0, then S is equal to S prime. Do the same for the other members. Okay, so this is the correct value of the force of all members. Sorry. This is not included. No. For this member, this force is for this member. The line was removed. Okay. So for R prime, for R, let's choose R prime. R prime is 48. Diba? 48. But then our U is 0, 0. So therefore our R is 48 lang. And this one, 16 also. Sorry. There's the member, CD. Okay, so I hope na you have learned something from this video. You can try member CD as the redundant. And you will get this one. Being the redundant. Positive 13.197. So thank you for watching.